Assalamualaikum and good day to my panels Dr. AKM Zakir and Madam Azian. My name is Nurul Aida Sukma Binti Amran, student from Bachelor of Electronic Engineering Technology in Telecommunication from Faculty of Electrical and Electronic Engineering Technology at UTEM. My supervisor name is Dr. Muhammad Inam Abbasi from FTKEE. I am here to presenting my bachelor degree project on title Development of Transparent Antenna Using Water as Conducting Material. First of all, do you know what is transparent antenna? Let me explain briefly about my project in the next session.
Okay, for my project description, an antenna is a device that connects radio waves to space-based electric currents. It works by absorbing the energy from radio waves and returning it to the transmitter or receiver. For my introduction, the transparent antennas may play an essential role in wireless communication networks in the future. However, the antenna material used now are quite expensive and low transparency. Therefore, to increase the transparency and improve the material of the antenna, the development of water-based transparent antenna had been proposed. The objective of this project are to study the feasibility of optimum antenna design using water as conducting material. Second, to characterize the properties of different samples of water in order to study the effect of conductivity of antenna performance. And lastly, to propose an optimum water-based microstrip patch antenna. The problem statement of my project is the cost of the antenna materials have become exceedingly expensive. The material have low transparency, which is less than 70%. And this is my methodology of my project. And this is my result and analysis of different parameters of my antenna, which are length of patch, width of patch, height of patch, and epsilon of material. For the epsilon of material, it contribute to 4 sample of water. And this is my design of antenna. For my project features, the transparent microstrip antenna is made consisting of a thin lead glass and lead glass substrate and distilled water as the patch and the ground. This antenna is 100% transparency. For my project potential of commercialization, the transparent microstrip antenna is made consisting of thin lead glass substrate and the antenna patched with distilled water. For the conclusion, the project was successful design the transparent antenna using water as conducting material that is 100% transparent material, low cost and easy to get. Other than that, this antenna had achieved below the -10 of S parameter value. This project had analyzed some different simulation to achieve the objective of better antenna. The different value of epsilon which represent the various sample of water, which is 4 types of water in design, the transparent antenna had been analyzed.
That's all my poster presentation. Next, I will show you my project demonstration. Let's go.
Okay, before I continue my project demonstration, I will show you the 4 sample of water, which is seawater, tap water, rainwater and distilled water. Okay, for the design, first I will create ground and patch using distilled water material. And then for the substrate, I use lead glass. Because of this antenna is transparent, so I use glass and the water as the conducting material. For the substrate of material, the permittivity is 6, and for the distilled water, the permittivity is 78.4. So after I had designed this antenna, I will add on the port, which is at the bottom of microstrip feed. So after that, I will go to the setup solver to run the simulation. at 2.45 GHz. So after I had run the simulation, it will show the S parameter value. Oh, before that, I will use parameter sweep to run various of parameter value to get the exactly return loss and bandwidth to get the better performance of antenna. So for the width of patch, I analyze from 30 mm to 40 mm, and then I continue run to get the graph, and next I will analyze the value of width of patch from 40 to 45 mm, and then I also analyze the substrate of height from 1 to 1.6 mm. Lastly, for different types of water, I use a new material, and then I declare the permittivity for the permittivity material name is ER. So I analyze using parametric sweep from 70 to 85, and then from the result navigator, this is the result that I have run. For example, on this I use different value of width of patch, and then I will get this graph result for return loss, and also for the VSWR I get like this. And then same also like this one for epsilon, the permittivity of the material. So I use the value of 70 until 85. So the value of S parameter will be different. So from this, we can conclude that we can conclude the effect of return loss and bandwidth through different parameter value of the antenna.
So, that's all my presentation of Bachelor Degree Project. I hope you enjoy watching this video. Thank you.